Okay, welcome to this video where we'll be going through a Foundation Paper 1 practice paper for all the topics on the Advanced Information list. Now this paper is going to be around about 80 marks, but it's not bang on, and I am going to be going through it pretty quick. So I will be linking in the description all the appropriate lessons and videos that are linked to these questions, so you can always check those out as well for a more in-depth explanation, but I will try and explain these as best I can as I go through. We've got a lot to get through, so we're going to get started, but just fair warning, I am going to go pretty quick, so if that's not for you, you may want to be pausing the video, or you may want to be trying some of my other revision videos, but we're going to go through a practice paper here, and we're going to go through that relatively quickly. So we've got a lot to get through, so let's get started. Okay, so looking at our first question. So it says here, write the numbers in order of size and start with the smallest. So we're looking for the biggest negative, and that is -6. Then we've got -5. Then we have 0, and then we've got 6, and then we've got 12. So just working up like a number line there. So that's ordering negative numbers. We now have to order some decimals. So again, starting with the smallest, write these in order of size. So I like to balance out all the decimals, so I'm going to add a 0 onto that 0.78 and the 0.87. Now I'm just going to read the number after the decimal. So we have 78 here, that's our smallest. So 0.078. Then we have 0.708, so 0.708. Then we have 0.780, so 0.78. And then we have 0.870, so 0.87. And there we go, and just notice I wrote those original decimals back in that position there when ordering them. So there we go, that's ordering some decimals. On to our next question, we are working out a fraction of an amount. So we're working out 1/5 of 70. So to work out 1/5, we would divide by 5. Now you might know a little trick for dividing by 5, but if not, just do 5 into 70. 5 goes into 7 once, remainder 2, and it goes into 20 4 times. So 1/5 of 70 is 14, and of course if you were asked to work out something like 2/5, you'd multiply that by 2 as well, but it only asks for 1/5 here. Next question, it says Fiona has to work out the exact value of 48 divided by a half. She writes that 48 divided by a half is equal to 24. Fiona's reason is there's 2 halves in 1, so there'll be 24 halves in 48. Explain what is wrong with Fiona's reason. Well, if there's 2 halves in 1, which is true, that means the answer doubles. So if you were to do 1 divided by a half, you'd get the answer 2. So 1 has turned into 2. So in our example here, 48 divided by a half would actually double the answer. So we could say something along those lines. So 48 divided by a half would actually equal 96. Or in other words, you double the answer. So actually you're doing 48 times 2, which is equal to 96 as well. And you could write some words along with that, but my mathematical explanation is good enough there, and you could write some words along with it. On to the next one. We have changed 350 centimetres into metres. Well, there's 100 centimetres in every metre, so you could divide that by 100 if you want to write it as a division, but the answer would come out as 3.5. As there's 100 centimetres in every metre, we have 350 centimetres. So we've got a percentage of an amount here, so 15% of 80. So without a calculator, we're going to work out 10%. So hop your decimal in or divide it by 10, which is 8. 5% we need as well, so we want half of that, which is 4. And then we want a total of 15%, so we'd add those two together, and that gives us an answer of 12. So we'd say 12 is our answer. And of course, if you needed a higher percentage, like 35% or something like that, you could times the 10% by 3 and then add your 5%. There we go, we only needed 15% there. So our next question here, we have adding fractions. So when we're adding fractions, we need a common denominator. So I'm going to multiply the left fraction, top and bottom, by 5, and the right fraction, top and bottom, by 7. That's going to make 2 fractions where we have a denominator of 35. So the left numerator there, 2 times 5 is 10, and the right numerator, 1 times 7 is 7. So if we add those two together, we'd get 17 over 35. On to dividing. We have to first make our mixed number an improper fraction. So big times the bottom at the top would be 5/3, and we're going to divide that by 3/4. So when we are dividing fractions, we're going to keep the first one, 5/3, and we're going to multiply by the reciprocal, flipping it over, so 4/3. 5 times 4 equals 20, and 3 times 3 equals 9. So I've written my answer as 20/9. It doesn't ask me to write it as a mixed number, so I can leave it as 20/9. And there we go. So on to our next question. Express 56 as a product of prime factors. So for 56, I'm going to write 56. I'm going to do a prime factor tree. I need to get these first two correct. So as it's even, I'm going to divide it by 2. Half of 56, well, half of 50 is 25. Half of 6 is 3. So that'd be 28. 2 is prime, so I'm going to circle that. I'm going to go again. So that'd be 2 times 14. 2 is prime. And this would be 2 times 7. So we're just looking for what two numbers divide or multiply to make the number above. So as it happened, these all became even numbers. So that's very nice. So I could write my answer as 2 times 2 times 7, or I could incorporate powers, and I can write it as 2 cubed multiplied by 7. And either one of those answers is fine. On to our next one. Amzol is paid £1,500 per month. He's going to get a 3% increase. Work out the amount of money he's going to be paid after the increase. So I need to work out 3%. So I'm going to work out 10% again. So dividing it by 10, 10% would be £150. Now I can get 1% by dividing by 10 again, and that's 15. Of course, I could have done that in one jump by dividing by 100, but I like to always start with 10%. So for 3%, which is going to tell me his increase, I'd multiply this by 3. So 15 multiplied by 3 is 45. So he's going to get a £45 increase. So how much money will he be paid after the increase? Well, he's already being paid 1,500. We're going to add 45 to that. So we get 1,545. And there would be my final answer. On to the next one. A farmer has 20 boxes of eggs. There are 6 eggs in each box. Write as a ratio the number of eggs in 2 boxes to the total number of eggs. So give your answer in its simplest form. Well, there are 6 eggs in each box. So in 2 boxes, that would be 2 lots of 6. That would be 12 eggs in that box. For the total number of eggs, well, we have 20 boxes and 6 eggs in each box. So we need to work that out. So 20 multiplied by 6 is 120. So for the total number of eggs, that's 120. So as a ratio, we've got 12 to 120. And both of those numbers there, we need to simplify, as it says, to give it in its simplest form. And they both divide by 12. You could obviously take that in smaller jumps. You could divide by 2 and then divide by 6 or something like that. But I'm going to divide it by 12 straight away. So 12 divided by 12 is 1, and 120 divided by 12 is 10. So our ratio in its simplest form is 1 to 10. And there we go. There is our ratio question. Okay, so for our next one here, we have 3 kilograms of carrots cost £1.80. 2 kilograms of carrots and 5 kilograms of potatoes cost £3.45. And it wants us to work out the cost of 4 kilograms of carrots and 2 kilograms of potatoes. Well, we need to get the cost of 1 kilogram of each. So to start with, if I go with the 3 kilograms of carrots cost £1.80, I need to divide that by 3. That'll give me the cost of 1 kilogram. So if I do bus stop method again, and I can't divide 3 into 1, so 0. Carry the 1, and then it's 6, so 60. So that's 60p, but I'll leave it as 0.60. As I can already see on the dotted line, it wants my answer in pounds, so I'll keep it in pounds. So 1 kilogram of carrots equals 60p, and it does want me to work out the cost of 4 kilograms of carrots. So I'm going to times that by 4 as well. We may as well do that now as we're on the carrots. Times that by 4. So 4 kilograms of carrots. And you can take your time to do that. 60p times 2 would be £1.20. Double that again because it's 4. That would be £2.40. So it's £2.40 for 4 kilograms of carrots. Now we can work out the cost of the potatoes. Now it says 2 kilograms of carrots and 5 kilograms of potatoes cost £3.45. So those 2 kilograms of carrots would have cost £1.20. So the remaining amount is going to be the 5 kilograms of potatoes. So if we take that away from £3.45, let's just write that here, £3.45, take away £1.20, would leave us with £2.25. So that's 5 kilograms, so we'll divide that by 5. So 5 doesn't go into 2, so carry the 2. 5 goes into 22 4 times with a remainder of 2, and it goes into 25 5 times. So 1 kilogram of carrots costs 45p, sorry, potatoes. So 1 kilogram of potatoes, I probably could have just labelled these C and P, would have been a bit quicker. Potatoes is equal to 0.45, and ultimately we want to work out the cost of 2 kilograms of potatoes. So we'll times that by 2, and that would be 2 kilograms, let's just put P, equals, and that'd be 0.90, 45 times 2 is 90. So there's our two amounts. We have 4 kilograms of carrots is £2.40, and 2 kilograms of potatoes is 90p. So if we add those two together, again, working in pounds, you could have converted this into pence and then converted it back if you prefer, but I think that's okay numbers for us to have kept it as decimals. So 0 and 0 is 0, 9 and 4 is 13, carry the 1, and that's a 3 there, so that's going to be £3.30. So I'll just write my final answer, £3.30, and there is another question done. Okay, on to question 10, we are sharing in a ratio. So Harry, Regan and Keelan share £450 in the ratio 2:5:3. How much does Keelan get? So if we share this out, we want to know what's the total of our ratio here. So if we add that together in total, that's 10. 2 add 5 is 7, add the 3 is 10. So I'd want to start by doing £450 divided by 10 to see how much one part is worth, and that comes out as £45. Now with my ratio, 2:5:3, I just want to make sure I know which name is for which person, so I'll put H, R and K, and it wants us to work out the K, so we'd multiply that by 45. You could multiply them all by 45 if you want. 2 times 45 would be 90, 5 times 45 would be 225, and 3 times 45 is 135, and that's the number we're looking for, so £135. And there we go, they're sharing in a ratio. Okay, so we've got some simplification with algebra. So 5f take away 1f would be 4f. So at this point, by this point here, we've got 4f. Then we're going to add 2f to that, so in total, that is 6f. On to the next one. When we're multiplying, we're just going to write the letters next to each other, unless they're the same letter, which would increase the power when we're multiplying, but they're not. We've got an m and an n, but the numbers we can times together. So 2 times 8 will be 16, and then we just write the letters next to it, and that just means 16 times m times n. So 16mn. Make sure we get rid of all those multiplication symbols. We have t squared add t squared, or you could write that as 1t squared add 1t squared. So in total, we have 2t squareds. Remember, when you're adding together, you don't increase the powers. We're just collecting how many t squareds together that we have. There is some of our simplification. So for this question, we've got some estimating. So Paul organised an event for charity. Each ticket cost £19.95. He sold 395 tickets, and he paid costs of £6,000, and he gave all the money left over to charity. Work out an estimate for the amount of money Paul gave to the charity. Well, as soon as it says that word estimate, straight away we're going to round all these numbers to one significant figure. So that will round to £20, and this will round to 400 tickets. So he is going to sell 400 tickets for £20 as our estimate. So 400 times 20. That's quick for us to work out now because we just need to times the first digits. So 4 times 2 is 8, and add those 3 zeros on. So that's going to be £8,000 that he gets for the tickets that he sells. Now he had to pay £6,000, so we'd want to take away 6,000, and that leaves us with £2,000. So he's going to give £2,000 to charity, and that'll be our final answer. So £2,000 is our final answer there. Is your answer to part A an underestimate or an overestimate? Give a reason for your answer. Well, let's have a look. So here, we've actually rounded up the amount of tickets that he sells, and we've rounded up the amount of money. So actually, it would have actually, let's have a think. He'd actually have got less money than £8,000, wouldn't he? So he'd have got less money than £8,000, meaning that when we took away the 6,000, it would have been less than £2,000 that he's given to the charity. So our answer there is an overestimate, and you could write as much detail as you want there. Okay, but the reason is because we've rounded both those numbers up. Okay, so we could say overestimate as we rounded two numbers up. I rounded the two numbers up. You could write more of an explanation if you wanted, but that's fine for that question. So we rounded them both up. So you could say actually he'd get less than £8,000 and therefore he'd get less than £2,000 to the charity. But there we go, it's an overestimate. Okay, so on this question here we've got a pictogram. So there are only apple trees, cherry trees and pear trees and plum trees in an orchard. The pictogram shows the information. There we go, so we've got the key there that says the full square represents 4 trees, and we've got these little bits, so we have like part of it there which would be 1 tree, half of it there which would be 2 trees, so we'll take that into account. There's a total of 30 trees in the orchard, complete the pictogram. Right, so let's count up what we got. Well, every full square is 4 trees, so that's 4, 4 and 4, that's a total of 12. This one is 4 and 1, so that's a total of 5. This is 4 and 2, so that's a total of 6. And let's see what we've got left over. So at the moment, they all add up to 12 add 5 is 17, plus the 6 is 23. So if we do 30, take away 23, we have to get another 7 in terms of our pictogram. So we put a full square in, and that would be 4. And the last one here is a little bit awkward because none of the other shapes represent 3. So it'd be some kind of like L shape. That would be 2 plus a little square on the end, maybe a little L shape like that, and that would be 3. And that would give us 7 in total. So there we go, there's our pictogram completed. Question 4, we've got a sequence, a linear sequence, so write an expression in terms of n. So at the moment, our sequence is going up by 4, always check another one there, so that's going up by 4 as well. So it's the 4 times table, so we write that that is 4n, and then we've just got to say how much bigger or smaller than the 4 times table it is. So you can either go back to find what some people call the 0th term, or we could just think, right, well the 4 times table starts with a 4, this starts with a 6, so it's 2 bigger. So it's the 4 times table, but with 2 added on. That's 4n plus 2. Right, so it says the nth term of a different sequence is 3n plus 5, is 108 in the sequence. Show how you get your answer. So what we could do is substitute numbers in place of n. So you could do things like 3 times 20, which would be the 20th term, and then add 5, and that would give you the answer 65. It's obviously going to be quite a slow method. We know we've got to go bigger than that, but there is a quicker way than doing that. But that's a fail-safe method. If you're not sure, you can always come back to it at the end. But hopefully you'll be happy with this process. We'll say that 3n plus 5, does it ever equal 108? Because 5 is going to be added onto each number. So if we take away the 5, does 3n ever equal 103? Okay, so this is basically saying, is there a number we could have times by 3 and added 5 to get 108? Well, take away the 5 is 103. Does that divide by 3? Well, there is a trick for dividing by 3. If you add up the digits, you can see if it's in the 3 times table. So I know this doesn't because 103 adds up to 4. That's not in the 3 times table. That's just the digits there. But we could show that via a division. So 3 goes into 10 3 times, remainder 1. And then it goes into 13 4 times with another remainder of 1. So we end up with a decimal. So I would say no, I've shown how I got my answer because I've shown that division there. But no, I would say 108 is not in the sequence. Okay, on to our next one. Show a shop sells desktop computers, laptops and tablets. A composite bar chart shows information about sales over the last 3 years. So you've got a few different bar charts you can have. You can have a normal bar chart, where it's just the bars and it just shows what they've got. We've got dual bar charts, where the bars are drawn next to each other. And this is probably the worst one, a composite bar chart, where the bars are stacked on top of one another. So these ones are stacked on top of one another. Let's have a look at what we've got. Write down the number of desktop computers sold in 2015. So look at our key, that's the black or the solid bar. So in 2015, if we just trace across, you do this with a ruler, be really carefully, that's on 100. So there's 100 desktop computers sold in 2015. Make sure you do that with a pencil so you're not drawing all over it all the time. Work out the total number of laptops sold in the 3 years. Now this one's a bit more awkward, so that's the one just here that's been partially shaded in. So we need to work out each bar and see what we get. So in 2015 it goes from 100 to there. Now each little square goes up by 20, so that's 260. So that is from 100 up to 260. So that's going to be 160 laptops in 2015. So let's just write down 160. We're going to have to add the next year. The next year, again, you can see how much you could draw all over this. That is just above the 100, one square above. So that goes from 120 up to this point here. When we trace across, that's 340. So from 120 to 340 is 220. So we'll write down 220. Again, you can write down as much working out if you want. I'm going to get rid of that. Again, if you've got your ruler, you can hopefully just read this. If I go across from here, this one's not very nice because you've got to go all the way through the bars. That is 3 squares above. It got a bit wonky at the end, but that's gone from 160 up to 440. There we go. So that one's not very nice. Add 40 gets you to 200. It's 240 bigger than that. So that is 280. So we're going to add that to 280. So add those all together. Let's see what we get. 280 add 220 is 500. Add the 160. That's 660. That's not a very nice one. To be fair, look, that was 3 marks. So you got quite a lot of marks for that. So it was quite a fiddly question. But there we go. That is reading those values. Not the nicest there. We've got a part C as well. State the item that had the greatest increase in sales over the 3 years. That's not very nice. Hopefully we can just see that by looking at it. Well, actually, yeah, you can definitely see which one has had the biggest increase because you can see that the tablets here have gone from only having 60 tablets sold in 2015 to having a huge bar of tablets there. It goes from like 440 all the way up to like 780. That's over, over 300 there. So that is definitely going to have our biggest increase. So we would write down here, we'd say tablets. And you could say something along the lines of, I think they over doubled each year. So this one here went up, yeah, I mean, they're the only one to have doubled each year. You can see visually, tablets over doubled each year. There we go. You could even say some of the numbers. You could just write there, as we can see from the graph. On to the next part. Alex says in 2017, more tablets were sold than desktop computers. This means the shop makes more profit from the sale of tablets than from the sale of desktop computers. Is Alex correct? You must justify your answer. Well, we can't actually make that statement because we do not know the cost or the price or the profit on either of those items. So no, as we do not know the cost or the profit of the item. Or for each item. There we go, so we just don't have enough information to make that statement. Okay, on to our next question. So we are doing a reflection here. So reflect the shape in the mirror line. So let's pick each corner. So here we go 2 squares away from the mirror line. This one here is 4 away. So that's going to go there. And count these very carefully. This one's 3 away, so that's going to go there. This corner is 1 more square away, so that's there. Let's see, how close are we? Up to there. Bring this down. Join it all together. And there we go. That's a reflection. Obviously, bear in mind this could be on a graph. If you imagine that maybe this is the x-axis, that's the y-axis, you could potentially be asked to actually draw the mirror line in yourself. So you need to know things like, if we imagine this was x is 1, that this line here could be called x equals 1. So you could have to reflect it in a line and draw the line in yourself as well. As well as that, you could obviously be asked to reflect in a y equals line. So maybe going across like this, you could have y equals 1 as well. But this one's just drawn on a nice little simple grid, but you could have to do it on an actual coordinate graph too. Onto a stem and leaf diagram. So for this stem and leaf diagram here, it says find the median speed. Now it tells us it's 27 cars, so that's quite nice because we can cross off from either end, or we could do things like adding 1, dividing it by 2 to find a median in a statistical way. So you can either cross off 1, 2, 3, 4, 5 from each side and keep doing that little process, or instead of drawing all over it, you can actually find the middle by adding 1 to 27, so 27 plus 1, and then divide that by 2. So that's 28 divided by 2 is 14, so we just need the 14th number. So that's where our median will be. You can go from the start or the end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and there's the 14th number. So that is a 5 and a 6. Look at the key. So that is going to represent 56, as 3/8 was 38. That's going to be 56. Next one, work out the range. That's the biggest, take away the smallest. So our biggest number is 70, our smallest is 38. So our working out for that would be 70, take away 38, and the answer for that is 32. So there we go, there's our range. The next question says, one of the cars is chosen at random. Jack says the probability that the speed of this car is more than 60 miles per hour is 1/3. Jack is wrong, explain why. Well, let's see how many cars are over 60 miles an hour. So we have all of these, and we have this one here. So that's 1, 2, 3, 4, 5, 6, 7, 8. So 8 of them are over 60 miles an hour. So that's 8, and that's out of 27 cars. Well, 8 over 27 is not equal to 1/3. So that does not equal 1/3. So I could write an explanation there. I could just say that 1/3 would actually be something like 9 over 27. Yeah, so you could times both top and bottom by 9, and this is 8 over 27. So 8 over 27 is not equal to 1/3, and that would be a fine explanation. Okay, so we're drawing the graph of x squared plus 1, and here is the graph. And straight away, hopefully you can see a quadratic graph should be drawn with a nice smooth curve, and that's been drawn with straight lines. So here it says write down one thing that's wrong with the graph. We would say here the graph should be drawn with a smooth curve. Okay, it looks like it's been drawn with a ruler. Okay, drawn with a smooth curve. And you could obviously actually be asked to plot the graph yourself, and if you are, you'd probably be given a table as well. So normally you'd be given a table, you'd have the x values, which would normally come from the graph down here, so it goes from like -3 to 3. So maybe it goes -3, -2, -1, etc. You have to find the y coordinate. You substitute it in, so you do x squared add 1, so -3 squared is +9, add 1 is 10, -2 squared is 4, add 1 is 5, -1 squared is 1, add 1 is 2. And you just plot the graph yourself, but obviously just make sure you join it up with a nice smooth curve. It should make that nice U shape, as you can see on the graph there, but with a nice smooth curve. Okay, on to our next one. So we have a cube. The diagram shows a cube of side length 2. Okay, so we have the volume of any solid made with 6 of these cubes is 48 centimeter cubed. Is Vera correct? You must show your working. Well, to get the volume of a cube, we multiply together the 3 sides, so 2 times 2 times 2. So if we do 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. So the volume of this cube is 8 centimeters cubed. So if we had 6 of these cubes, the volume we would times by 6. So 8 times 6 equals, and that equals 48. So that equals 48 centimeter cubed. So yes, Vera is correct. So we've got our working out there. So yes, as 8 times 6 equals 48. And that's a fine answer. Here it says draw a cuboid that can be made with 6 of these cubes. Write the dimensions of the cuboid on your diagram. Well, there's loads of different ways that you could do this. So we could just do, and it's a bit awkward to draw actually, but we could just draw one long cuboid that's made up of 6 of these cubes, all just lined next to each other. So you could try and split it up into 6, 4, 5, 6. There you go. We'd obviously see those little bits along the top there. So that would be 2 going up as our dimension, so 2 centimeters. That would be 6 of them going across, so 6 times 2 is 12 centimeters. And that would have a depth of 2 centimeters as well. So you could obviously draw that vertically, or you could stack cubes on top of one another, but that's probably the easiest way of drawing one. Okay, so here's a number line. On this number line, show the inequality -2 is less than or equal to x is less than 3. So -2, circle, 3, circle, join them up when you have a joint inequality, and shade in the circle that has any extra ink on the inequality. So that one is less than or equal to, that less than or equal to symbol, so we colour in that circle. And there is a number line inequality. This one we have to solve, so we solve it just like an equation. We're going to -3 from both sides, so 5n is greater than 24, and then we have to divide by 5. Now straight away you can see that doesn't divide by 5, not to give you a whole number, so if we can't divide, we'll just leave it as 24 over 5. So that just means 24 divided by 5, but we'll leave the answer as a fraction. You could convert it if you want into a mixed number, try and write it as a decimal, but it's fine to just write that as 24 over 5, which is 4 4/5, which you could write as 4.8 if you like, but you don't have to. Okay, so there's solving an inequality. So this next question, we have a frequency tree. So 60 people took a driving test. 21 of these people were women. 18 of the 60 people failed their test, 27 of the men passed. To use this information to complete the frequency tree. So 21 of them are women, so we can put that straight away there. Now there's 60 in total, so if we take that away from 60, that's going to be 39 that are men. It then says 18 of the 60 people failed. Okay, that's a bit awkward because that's both of them, but they have to add up to 18, so we'll write that like that for the moment. 27 of the men passed their test. So 27 men passed, which means that 12 failed. Now, if 12 men failed their test, we know that 18 people failed. That would make this one 6. And now we can work backwards because there's 21 women in total, so that must be 15 that passed. So there's our frequency tree completed. It says one of the men is chosen at random. Work out the probability that the man failed his test. So as it says one of the men is chosen, this is only going to be out of the men. So that's going to be out of 39. It says write down the probability the man failed, while 12 of them failed, so we have 12 that failed out of the 39 men that were chosen, so our probability would be 12 over 39. And when it comes to writing probability, don't forget, you don't even have to try and simplify the fraction. So 12 over 39, final answer. Okay, so plans and elevations. So it says here on the grid, draw the side elevation from the direction of the arrow. So when I'm drawing a side elevation, I'm definitely going to want to draw it the same height as the front elevation here. So the shape here is going to be the same height as the front. So I'm just going to draw that 4 squares up. Now from the plan, you can see that it's 2 squares in width. We're looking at it from there as well. So we would see those 2 squares in width. So it's going to be a rectangle from the side going up. And then we just want to draw in any of the lines where the height changes. So you can see we have one here and another one there. So I draw one line going across to show that height change, and this one going across here to show that height change. So there we go, there is our side elevation. That's looking at plans and elevations there. Okay, onto some standard form. So writing this in standard form, we want to hop our decimal, 1, 2, 3 jumps. So that would be 5.49. It's a 0 point number, so it's times 10 to the power of -3. And there is our standard form conversion. For a standard form calculation, we've got a bracket squared, so a little bit different, but that's going to be 8 times 10 to the power of 3, multiplied by another 8 times 10 to the power of 3. So when you're doing this, you times the starting numbers together, so 8 times 8 is 64, and we're going to add the powers. So add the powers becomes 10 to the power of 6. Now that has to be written in standard form, so 64 we need to drop down to 6.4. And if we've made the number smaller, we balance it out by just making the power bigger. So it's 6.4 times 10 to the power of 7. For the next one, there's no quick tricks for this, unfortunately. We're going to have to just times it out, 1, 2, 3, 4, 5, and then add them together and put it back into standard form. So the next one is 8 and 7, 4 jumps out, 1, 2, 3, 4. Add them together, so I'm going to line them up using column addition. I'm just going to go straight underneath this one, so 1, 2, 3, 7 and 8. Add them together, 0, 0, 0, 7, that's 14, so carry the 1 and an 8. And if we convert that back into standard form, I've got to go 1, 2, 3, 4, 5 jumps back in. So 8.47 times 10 to the power of 5. Okay, on to our next one. Gary drove from London to Sheffield. Right, so we've got some speed, distance, time here. Right, so it took him 3 hours at an average speed of 80 kilometres. Lynn drove from London to Sheffield. She took 5 hours. Assuming that Lynn drove along the same roads as Gary and did not take a break, work out Lynn's average speed from London to Sheffield. Okay, so we know with speed, distance, time, and this is one where we could possibly use the formula as well, rather than a slightly different method sometimes for non-calculator questions. We know we have the time, 3 hours, and the speed. So we have the time, 3, the speed, 80. To work out distance, we times them together. So that would be 80 times 3, which is 8, 16, 24, so that's 240, and it's in kilometres, so that's kilometres. So that's the distance. So if Lynn has driven along the same roads, she has done the same distance, but it took her 5 hours. So in order to work out the speed, we do distance divided by time. So we do 240 divided by 5. Now you might know a trick for dividing by 5 as well. Last time I used bus stop, this time I'm going to use the trick, which is to divide by 10 and double the answer. 5 goes in twice as many times as 10. So 24 divided by 10 is, 240 divided by 10 is 24, and then double that. So that's going to be 48. So our speed, and let's just look at the question, was in kilometres per hour. So that's 48 kilometres per hour, although kilometres per hour is on the dotted line for this question, so that would be 48 as our answer. If Lynn did not drive along the same roads as Gary, explain how this could affect your answer. Well, if she didn't drive along the same roads, she could have done a larger or a smaller distance, and therefore her speed could be different, but it could be higher or lower. So she may have driven, you could say, any of what I've just said there, she could have driven a higher distance, therefore her speed could be higher or lower. There we go, I won't write out everything I've said, but her speed could be higher or lower. And the reason there is because she could have driven a higher or a lower distance. Okay, so next question. Right, so this question here, we have to work out the weight of this metal frame. So it says the frame is made from 5 pieces of straight metal, which we can see. It's in the shape of a rectangle, which we know because we've got those right angles. So this is going to be 5 as well. This is going to be 12, but we need to work out that diagonal distance. So to work out that diagonal in a right angled triangle, we'd use Pythagoras. So for that there, we'd do 5 squared, add 12 squared. Now if you add those two together, that's 25 add 144, that's 169. And for Pythagoras, we square root our answer, and that gives us our length, and that is 13. That's one of those square numbers you need to know on a non-calculator paper. So that is 13. And now we can add those all together. So if we add those all up, you've got 5 plus 5 plus 12 plus 12 plus the 13. That adds up to 10 plus 24 plus 13 is 47. And it tells us that the weight of the metal is 1.5 kilograms for every metre. So if every metre weighs 1.5, we'll do 47 metres multiplied by the 1.5, and that you can do 2 different ways. So timesing by 1.5 adds 50% on, or we hop the decimal out, we'll do 47 times 15, and then hop the decimal back in. So 5 times 7 is 35, 5 times 4 is 20, add the 3 is 23. Put your placeholder for the tens, 1 times 7, 1 times 4, add those all up, 0, 1, 7, so 70.5 when we hop the decimal back in. So our final answer there is 70.5. Okay, on to our next question. So write down the exact value of cos 60. Now cos 60 is just one of these ones you need to remember for this paper, and the answer is 1/2. The other one that has a value of 1/2 is sine 30. So for this question here, part B, let's see, we have given that sine 30 is 0.5, so it's given us the other one on part B. Work out the value of x. So this is using SOHCAHTOA. We have our opposite and we have our hypotenuse. So we're going to use sine, so SOH. We're working out the opposite, so we cross that out, so it's S times H. So normally with Socrates we do sine 30 multiplied by the hypotenuse, which is 12, but this has told us that sine 30 is 0.5, so it's 0.5 times 12, and if you times anything by a half, it halves it, so 0.5 times 12 is going to equal 6. So the answer is 6, and it's in centimetres. There's no centimetres on the line there, so we'll put centimetres as well, and that'll be our final answer, 6 centimetres. Okay, on to our next question. Okay, so we have solving a quadratic. Now when we're solving a quadratic, we need to factorise it. So we're going to factorise this. It's equal to 0, so that's fine. Two numbers at times to make 24. We've got 1 and 24, 2 and 12, 3 and 8, or 4 and 6. So out of those two numbers, which two can we make positive 5 with? So we can do that using 3 and 8. So in our brackets, when we factorise it, we want x plus 8, and then take away 3, and 8 take away 3 would equal 5. So that's all equal to 0 still. So when we are solving, all we do is we flip the symbols in those brackets. So positive 8 gives a solution of negative 8, and negative 3 in the bracket gives us a solution of positive 3. So our final answer here would be x equals minus 8 and x equals 3. And there we go, there's our final answer. On to our next question. We must be getting pretty close to the end here. Let's have a look. Yep, that's the end of the paper. So for this one, Sanders has a water tank for storing rainwater, and you can see we've got a cylinder. It says the tank is in the shape of a cylinder, the radius is 31, the height is 97.5, which we've got on the diagram. The tank is full of water. Work out an estimate for the volume of water in the tank and give your answer in litres. You must show you're working. It's told us here that 1,000 centimetre cubed is 1 litre. So for working out the volume of a cylinder, the volume is going to be equal to the area of the circular face, pi r squared, multiplied by the height. And we're also going to be estimating. So I'm going to use 30 as my radius. I'm going to round the height to 100, so just to one significant figure. So if we just write those into our formula, the volume is going to equal pi r squared h. Now, as we have pi involved, we're going to use pi as the number 3. So our pi is obviously 3.14, but we're going to round that to one significant figure and use the value 3. So that's going to equal 3 times 30 squared times the height, which is 100. So let's work that out. Well, that's 3 times 30 squared. We could write that to the side. 30 times 30 will be 3 times 3, which is 9, and 2 zeros. And then times by 100. 3 times 900 will be 3 times 9 is 27, and then 2 zeros, so it's 2,700 times the 100 still, and then times it by 100 adds another 2 zeros on, so 2700 with 2 more zeros is 270,000, and that is in centimetres cubed. So we have our answer in centimetres cubed. Quite a lot to do there. So actually rounding pi to 3 and the other values to one significant figure, and then also putting it into our volume formula. So to convert this into litres, we need to divide by 1,000, because every 1,000 litres is 1 litre. So if we divide that by 1,000, 2, 3, that'd hop the decimal in 3 jumps, 1, 2, 3. So that answer will be 270 litres. So for this question then, let's just have a look on the dotted line. It does say litres, so we just write 270, and there we go. That is our final answer. So there we go, that's the end of the paper. Hopefully that wasn't too quick, but as I said at the start, obviously this is our last sort of day revision, just making sure that you've gone over a practice paper nice and quick, and you can focus on any revision that you need to. So I'll link all the topics in the description, so check those out. Hopefully this was useful and helpful. If it was, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you for the next ones looking at paper 2.